There's many theories about what came before the Big Bang. One of them is that there was many bangs, just like the Big Bang, that had similar outcomes before it. Or there's a theory that a god or gods created the universe as we know today. Or there's a very scientific version that there was a very small, dense ball of energy that got so hot and built up so much pressure inside of it that it finally exploded. The ball of energy had infinite density. Inside the ball was inside a ball that was smaller than an atom by a lot.
Bam! Didn't catch that? I didn't think so. That's why scientists created Planck time so we can split up time and understand the greater details. When we split up this second, we can see the sequence of events up close and a lot slower, which can help us really identify what happened in those quick seconds of the Big Bang. Before the Big Bang, the forces were all combined into one superforce. These forces are called individually the strong force, gravity, the weak force, and electromagnetism. During the Big Bang, these combined forces broke apart and formed into the separate forces as we know them today. What we know about gravity today. Gravity force that binds the solar system together. It affects all the planets and stars. The strong force binds the nucleus. The electromagnetism is the force that binds the atoms together. The weak force is responsible for the radioactive decay of atoms. Let's pause and review all the characteristics of these four forces. Gravity. The weakest of the four forces that keeps the Milky Way and other galaxies in orbit. It's an invisible force that pulls objects closer together. Strong force. It underlines interactions between all particles containing quarks. When fully charged particles are put in motion, they create a magnetic field. But unlike gravity, electromagnetism is stronger but doesn't extend as far. The weak force is responsible for the decay of neutrons in free space. It's the only force that can change a kind of quark into another flavor. Other flavors are up, down, charm, strange, top, and bottom.
How/why did the universe expand? It expanded because the basic forms of nature were unified for reasons unknown. This sub-sized cosmos explained the explosion, giving a rise to space-time and the explosion of the universe. What caused the expansion? It basically was just the heating of the universe. You may ask, how did the universe expand faster than the speed of light? Well, when the universe was expanding, there was no matter. When it started expanding, no matter cannot go faster than the speed of light, but nothing can. That's basically what the universe was.
During the Big Bang, it started as a ball of hot energy which, through the cooling process where the temperature had to drop a few million degrees, turned quickly back and forth from energy to matter. Matter then cooled down so much that it began forming quarks, protons, neutrons, and electrons. The protons and neutrons get bonded together by the strong force to create a nucleus with the electron going around it. Matter versus antimatter. In the battle that matter won by one matter particle, and antimatter canceled out, barely leaving less than a billionth of how much matter did exist before the battle. This billionth created everything we know and other things we don't know about yet. E equals mc squared, where E represents energy, m is mass, and c squared is speed of light squared. The Higgs field, this was invented in the CERN laboratory in 2012, which basically says certain particles, like massless, like protons, don't interact with the field as much as other particles. The more interactions made, the more mass the particle gains. Mass comes from the interactions with a field. The Higgs boson is basically just a clump in the field that makes particles move very slowly.
How galaxies and stars formed. Over about the period of 3 minutes, protons and neutrons assembled from the annihilations to form the simplest atomic nuclei, while electrons scattered the photons, creating a soup of matter and energy. When the universe cooled below a few thousand degrees Kelvin, the loose electrons moved slowly enough to get taken from the soup by roving nuclei. The first atoms emerged were hydrogen, helium, and lithium, the 3 lightest elements. The universe is now visible to transparent light. These free-flying photons are visible today as cosmic microwave background. Over the first billion years of the universe, it continued to expand and cool until matter gravitated into massive concentrations called galaxies. Between 50 and 150 billion formed, forming billions of stars that undergo thermonuclear fusion in their core. Stars formed a significant amount of pressure in their core to manufacture dozens of elements. They would be useless just staying inside the star. So high-mass stars exploded, releasing their chemical-enriched guts throughout the galaxy.
How was the universe born? Einstein's theories about light, motion, gravity, mass, and energy began a new era of science that ultimately led to the thought of a new Big Bang theory. These theories also led to concepts such as black holes and dark energy, which we still don't really know that much about. Hubble's telescope. He discovered that the universe is still expanding from when the Big Bang first exploded, and he discovered a new way to classify stars and planets. With the telescope, he took his famous picture called the Hubble's Deep Field Image. This photo was deemed the most important image of the universe ever taken. This photo contained thousands of nearby and distant galaxies. The image represents only a tiny sample of our universe, but it's super important because it gave scientists the first look at galaxies when they were very young. Cosmic microwave background radiation is electromagnetic radiation as a remnant from an early stage of the universe during the Big Bang. It's a faint cosmic background radiation that fills all of space and is just now reaching us. CERN experiments have also helped us recreate the Big Bang. We can smash different particles together, similar to how the Big Bang exploded, and then during the cooling process, they created different kind of particles.
How will the universe end? Or will it ever end? We don't know. There are 3 quite possible theories that have been studied to this day. The first one is heat death. All of the stars in the cosmos will burn up their fuel, most of them leaving a dense remnants known as white dwarfs and neutron stars left behind. There's the second option called the Big Crunch. By contrast, galaxies would one day start pulling the universe back together again, making everything just a dense spot again. And lastly, there's the Big Rip. Dark energy acts in opposition of gravity and pulls everything apart piece by piece. The cosmos expansion accelerates until distant galaxies are moving away so quickly that light can no longer be seen. And that's how the universe will end, if it ever does.
Bye, cruel world.